This diagram on the left shows the normal model with its its mean mu and standard deviation sigma, and you can see we've marked mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, and then mu minus sigma, minus 2 sigma, minus 3 sigma. We also have the 68, 95, 99.7 rule shown. These values slip down a bit. This is actually supposed to be kind of, if we move each one of these up, the top one is supposed to be the 68, the middle one is the 95, and the lower one is the 99.7. Slipped a little bit on my diagram. Now, I want to define the standard normal model, but before I do that, let's define a couple variables. Let's say x equals the data values which are on the x-axis. Notice we don't have any specific numerical values here, but these numbers down here represent whatever my data is. In the last example, it was 12-year-old boys' heights. Okay, so whatever those data are. Now, a z-score, you know, is the standardized score. So to convert to the standardized score, we're going to have to use our z-score formula. So remember that the z-score, which I'm just going to call z, is the data value minus the mean divided by the standard deviation. Well, the data value here I'm going to call x. The mean is mu, and the standard deviation is sigma. So now we're going to use these letters, these symbols, to represent data value minus mean divided by standard deviation. And we're going to look at converting from the regular normal model to the standard normal model. So we're going to start and say, what if x was equal to mu? In other words, the mean. X is equal to the mean. How do I convert that to a z-score? Well, I use whatever my x value is, in this case mu. I subtract the mean, and I divide by the standard deviation. Well, mu minus mu is 0, so this would give me a z-score of 0, which we see as the mean of our standard normal model. Let's look at another example. Let's say x is equal to mu plus sigma. So we're looking at this value right here. Well, when we use our z-score formula now, then z is equal to mu plus sigma minus sigma all over sigma. Well, mu plus sigma minus mu, I think I said mu plus sigma minus sigma. Mu plus sigma minus mu is just sigma over sigma, which is 1. So when we are one standard deviation above the mean, the z-score on our standard normal model is just 1. Let's just do one more example, although I'm sure you can see how this works now. Let's say x is mu minus 3 sigma. In other words, I'm looking at this one right here. So z now is mu minus 3 sigma minus mu all over sigma. Well, mu minus mu is 0, so this just turns out to be negative 3 sigma over sigma, which is negative 3, giving us this value on the standard normal curve. So you can see that this distribution is just a distribution of z-scores. And I'm going to make that so it's a little more clear that that says z. And it's the same for any mu and sigma. By doing what I did below here, I showed that no matter what mu is, the z-score for mu is always going to be 0. The z-score for any mu plus 1 standard deviation is always going to be 1. So this standard normal curve then can be used to represent any set of data once we've standardized the values in the data. And this allows us to use what's called the standard normal table to help us find areas under the curve to answer questions about a normal model, which we're going to do in the next video.